Hello viewers, welcome to another practical session of your MOOCs course Internet of Things, Design Concepts and Use Cases. In today's session, we are going to learn interfacing IR sensor with a servo motor, and of course, we will be utilizing Arduino Uno board for this connectivity. First of all, let us see the connection diagram that you can see right now on the screen itself. I have shown both the equipments that I will be using. First of all, you have the motor one, and in this we have a cap, or we can say a tiny fan like structure connected on the top of the servo motor just to show the movement of the motor, and the motor comes with 3 wires itself. Each one of these wires have their specific meaning. You can see one red wire, which is the middle one. In most cases, in most motors, you will find the middle one as red wire, which represents plus 5 volt connection or your VCC connection. Similarly, the brown wire on the motor terminal is your ground, and the orange wire is your signal terminal through which you will be sending your output with a PWM wave. So, that is automatically transferred from your Arduino board. Now, at the same time, we have the IR sensor on the screen. This particular sensor consists of a IR emitter and IR receiver. It means it will keep on sending signals from the transmitter or emitter, and it gets reflected from an obstacle if it comes on the way of this particular sensor. So, that based on that reflection only, the receiver will receive a signal and it will detect presence of obstacle in the surrounding environment. And this particular sensor also comes with a potentiometer pot to adjust the distance level. So, depending upon how you want to use this particular sensor and up to how much distance you want it to allow to sense a obstacle. So, accordingly the potentiometer can be adjusted, and of course, that you already know, because potentiometer adjustments we have done in previous several sessions as well. Other than this, we have 3 different pins on the sensor itself. One is your 5 volt pin, or you can also connect it with 3.3 volt, it works on both signals, and we have one ground pin, and one is your digital output pin that you will be utilizing to send your signal to the Arduino terminal, and of course, you will be connecting it on the digital port of the Arduino. So, now based on this 2 devices that we have, I have designed a simple circuit diagram over here. It has few simple connections. First of all, the ground terminal, VCC terminal of both these devices is connected to respective ground and VCC terminal of your Arduino board. So, whether you take it through a breadboard or you can take it directly from your Arduino, depending upon availability of your 5 volt and ground terminals on the chip. And other than this, the signal pins of both these devices you have to connect on specified pins on your Arduino board. So, the same circuit now I am creating on the hardware side, and to show the outcomes, I will be also using a LED in sequence, so that the obstacles, the senses of that obstacle we can show with the help of an LED as well. So, here you can see, first of all, this is your motor with the same connections that I have shown you in the screen first of all. So, these are the 3 wires of your motor. You can see the brown, red and orange wires over here, and the same sequence I have extended further. You can see here we have extended this orange wire, I have extended with a blue wire over here, this red one I have extended with a orange one, and similarly the brown one I have extended with the black wire. If in your case, if you have similar color wire for the extension, that will be better, because for beginners the color coding is more important. So, this same connection I have extended here on my Arduino board. You can see the blue color I have added into the digital port over here, and similarly the ground and VCC terminals I have connected on the other ends. And in the similar manner, here we have your IR sensor. This IR sensor, as I have told you, it has transmitter and receiver over here, and this same transmitter and receiver we are using to sense the obstacle in the surrounding environment. I have adjusted the pot as well, and now we have these terminals. So, these terminals one by one, based on the VCC, ground and digital pin connection, I have extended further to my Arduino board. So, all these pins now you can see connected in different portions of your Arduino board, and at the same time I have added one LED terminal over here. So, you can see, as you already know, for LED we have one cathode, we have one anode terminal. So, one of these I have extended to the ground terminal, and other one I have extended to the digital pin that will be declared as an output pin over here. So, this is your entire hardware based circuit diagram, and now in order to interface this we need to design a code. So, that I will be doing with the help of your Arduino IDE platform. So, let us go back to your terminal, and here I am going to show you the simple sequence of codes. First of all, we have declared the LED pin number, which is pin number 2, because on the same position I have used it in my Arduino. Next, the obstacle pin or your IR pin I have connected on pin number 5, and then we have your servo motor pin, which is on pin number 3. And initially I have declared obstacle pin as high. It means there is no obstacle. So, this initialization you can do as per your choice, and throughout your program you have to utilize them in the similar manner. After this, I have included library from my servo motor. So, that is definitely essential in this case, and then I have created a serve object over here that I will be using to communicate with the servo motor throughout the program. After this, we go to the setup part, and in the setup section, first I have declared my input and output pins, which include your obstacle pin as well as LED pin, and other than this, for servo motor it has a attach function that we can utilize directly over here. And other than this, the serial monitor I have utilized with 1150-200 baud rate, or even if you want to change you can do it like 9600 baud rate. I have already told you that it works on both baud rates easily. Next to this, we have your loop section, in which I have created a if-else sequence to understand your IR sensor readings. So, it will first read your digital pin where we have connected your IR sensor. After this, it is first sensing if there is an obstacle or no. So, because initially we have kept it high, and now when we are doing it low, when the sensor pin is found as low signal, at that time it will state that there is an obstacle ahead, and the same thing we are printing on the serial monitor. And after this, we are writing the information on the LED pin, and next to this we have your servo motor, and this one is basically the angle of the servo motor by which the rotation will be shown on your hardware side. Then we are adding a delay of 100, and in the next sequence we can say the opposite of it, which means if the path is clear, what will be displayed on the LED terminal as well as on the motor terminal. So, this is your entire sequence of codes, and the same now we can utilize for the hardware terminal. So, first of all I am compiling it, and in the meanwhile I am attaching my USB terminal. So, you can see here I have inserted the board, and initially because I have already placed it on the ground, the sensor is on the ground and it is sensing here some obstacles because my arm is also around. So, it may initially show you some signals on the LED side as well as on the motor. Depending upon how you have adjusted the obstacle in the surrounding environment, for example, I am taking it up in this direction, and considering the position of obstacles around, we can sense if it works fine. So, as I am putting my hand ahead of it, so you can see some movements in the motor accordingly, and the same details will be published on your serial monitor. So, currently you can see it says something ahead, because in my case where I am sitting, I have some obstacles around. I have chairs and tables in the classroom here. But when you will be using it in a different environment with the open space, it will not be sensing any object over there, and as soon as you put a finger ahead of this, or maybe if you are designing a car parking system, so as soon as you put something ahead, the motor will rotate as per your choice. So, this creates a base for your parking management system. In the similar fashion, you can design a complete minor project or major project with parking management system, including some counters, including some LCD terminals, and maybe multiple IR sensors on the exit and entry terminal. And of course, the motor you can utilize with a barrier over there that can grow up and fall down based on the incoming and outgoing vehicles. So, I hope you enjoyed this video, and we can definitely utilize it further in creating your major projects or minor projects. So, thank you very much for this particular video, and keep learning new things.